Okay, guys, today we're looking at 10.4, which is special products, okay? The square of a sum is the first kind of special product we're going to take a look at. And this is essentially when we're squaring a binomial that has a plus b, or, one term plus another term. Okay, we looked at some of these when we were actually taking our binomial times binomial notes on what would have been Wednesday, okay? So let's take a look. The square of a plus b is the square of a plus twice the product of a and b plus the square of b. Okay, so that's our word definition. Sometimes the word definition helps a lot of us, sometimes it doesn't. So here's what it looks like in symbols. If we were writing this out as repeated multiplication like we do sometimes with an exponent, okay, we would take a plus b times itself twice. Okay, that's what this process is telling us to do here. Well, if I have two binomials written out like this, hopefully we know that we can FOIL this. So a times a would be a squared, a times b would be positive ab. Okay, b times a would also be positive ab. Okay, both of these would be positive ab. Multiplication is commutative, so it doesn't matter what order we do it in. Okay, and b times b would be b squared. Okay, and of course, hopefully we can identify that these like terms are in the middle again. ab and ab are like terms, so they would combine to create 2ab. So my final answer would look like that. A squared plus 2ab plus b squared. Okay, so that's kind of a symbol definition of square of a sum. But if we look at an example here, x plus 3 to the power 2, again, I can write it out as repeated multiplication. So x plus 3 times x plus 3. Okay, and then I can FOIL this. X times x is x squared. X times 3 is 3x. Okay, 3 times x is 3x. And then 3 times 3 is 9. And of course, my like terms are 3x and 3x. So I could say x squared plus 6x plus 9. Okay, so when we're taking the square of a sum, we're going to notice that there's this pattern here. We can square the first term, okay, and then we can square the second term, and those are kind of our outside edges. Our middle part here would be whatever our first term times our second term is, okay, and then we just double it. We take twice, okay, or 2 times it, okay. So let's take a look at some of these problems. The safest way to do these problems, guys, is always to write them out as repeated multiplication and then just FOIL them. Okay, but if you start to pick up on the patterns and you can jump from one to the other, then you're okay to do so. Okay, so x plus 6 times x plus 6, x times x for the FOIL, the f in FOIL is x squared, x times 6 would be 6x, 6 times x would also be 6x, and 6 times 6 is 36. Okay, after combining these two like terms here, I would have x squared plus 12x plus 36, right? And of course, if we look at this like our rule, we would square the first term, x squared, right there. We would multiply these two. 6 times x is 6x, and then double it, which would be 12x. And then we would square our last term, 6. 6 squared is 36. So there's that pattern being shown right there. But again, the safest way to probably do it is just FOIL it every time. Okay, number 2 is a little different. We have 2 different variables present, which really doesn't change our FOILing process for us. Okay, I would still write it out as repeated multiplication. 3g plus 10h times 3g plus 10h. 2 binomials. When I'm multiplying them, I FOIL. 3g times 3g would be 9g squared. 3g times 10h would be 30gh. 10h times 3g would also be 30gh. And 10h times 10h would be 100h squared. Okay, again, my like terms are right in the middle, so I would have 9g squared plus 60gh plus 100h squared. Okay, so that is the square of a sum. The next kind of special product we're going to look at is the square of a difference. Okay, but before that, let's take a look at this word problem. Okay, if we look at a Punnett square, hopefully you guys have heard of some Punnett squares, okay, in science class. They use Punnett squares to predict the probability of offspring inheriting certain genetic characteristics. So in Dobermans, black fur is represented by a capital B. It's the dominant trait over the recessive gene for brown fur, the lowercase b. Okay, so if 2 parents have both a dominant and a recessive gene, we need to use the square of a sum, what we just learned, to determine the possible combinations. Okay, so here's a look at a Punnett square, and what we want to do is we look at a binomial of capital B plus lowercase b to the power of 2. Well, I could write this out and FOIL it to get this exact same answer here. But what I did was I used the pattern of the square of a sum. I squared b, capital B, so b squared right here. And then I took capital B times lowercase b and doubled it. So 2 times capital B times lowercase b, right? And then I squared my second term, lowercase b squared, okay? This is the pattern we can follow when we're finding the square of a sum, okay? It makes it a lot easier and saves us a lot of time. But when in doubt, if you're not sure about it, if it's not making sense to you, you can always FOIL it. So capital B plus B as one binomial, and the second binomial would be exactly the same, and you would FOIL, and you should end up with the exact same answer here, okay? So now let's take a look at the square of a difference. The square of a difference is very similar to the square of a sum, okay? The square of A minus B is the square of A minus twice the product of A and B plus the square of B. So if we look at this as like symbols again, we're going to take A minus B times A minus B, and we're going to FOIL. A times A is A squared. A times negative B is negative AB. Negative B times A is negative AB. And negative B times negative B is positive B squared. Now when we notice my like terms, they're in the middle again. Negative AB minus AB, it's going to end up giving me negative 2AB. So I'd have A squared minus 2AB plus B squared. Okay, so this is very, very similar to the square of a sum with the exception of some sign changes. Okay, so let's take a look at an example. X minus 8 squared. Let's write it out as two binomials and let's FOIL. X times x is x squared. X times negative 8 is negative 8x. Negative 8 times x is also negative 8x. And negative 8 times negative 8 is positive 64. Okay, now let's combine our like terms to give me x squared minus 16x plus 64. Okay, so again, hopefully we're starting to notice these patterns as we work through some of these problems and see some actual examples. All right, let's take a look at an example of a square of a difference. Okay, I have find the parentheses 7d minus 2f close parentheses squared. Okay, so I'm going to write this out as repeated multiplication, and then I'm going to FOIL. 7d times 7d is 49d squared. 7d times negative 2f is negative 14df. Negative 2f times 7d is negative 14df, okay? And negative 2f times negative 2f is positive 4f squared. And now I can work into the process of combining like terms, okay? So I can take negative 14df minus 14df, and I can combine them, and I would get 49d squared minus 28df plus 4f squared, okay? So the square of a sum and the square of a difference are very similar ideas with one slight change, okay? The square of a sum, there's a plus sign. The square of a difference, there's a minus sign, okay? Our third special product we're going to look at is the product of a sum and a difference. So in this case, one of our binomials, okay, is going to have two terms and a plus sign separating them. And my second binomial is going to have the same two terms, but a minus sign separating them, okay? So if I were to FOIL this, a times a is a squared, a times negative b is negative ab, b times a is positive ab, and b times negative b is negative b squared. We notice when we combine our like terms here though, guys, they're actually going to end up canceling each other out. A negative ab plus ab is going to cancel out, and all I'm going to be left with is a squared minus b squared. Okay, so the product of a sum and a difference is really unique. This is what we call multiplying conjugates. Okay, these two binomials right here, x plus 6 and x minus 6, are the exact same with exception to one having a plus sign between them, one having a minus sign. Okay, they're called conjugates. All right, so if I FOIL this, x times x is x squared, x times negative 6 is negative 6x, 6 times x is positive 6x, and 6 times negative 6 is negative 36. And once again, when we look at the combining like terms step of this process, we notice they're going to cancel out. And all I'm going to be left with is x squared minus 36. Okay, so this is the product of a sum and a difference. All right, now we have two more examples that we're going to kind of look through here. All right, I have z plus 5 as my first binomial and z minus 5 as my second. Again, these are conjugates. They're the exact same terms, except one has a plus sign between them, one has a minus. So z times z is z squared. I know these are x's. Sorry, guys. These should be z's. Z times negative 5 is negative 5z. 5 times z is positive 5z. And 5 times negative 5 is negative 25. And once again, when we combine our two middle terms, our two like terms, okay, we're left with x squared minus 25. Okay. Number 2, we have 3y cubed plus 4 and 3y cubed minus 4. So again, these are conjugates, same terms, just different signs. 3y cubed times 3y cubed would be 9y to the 6th. 3y cubed times negative 4 would be negative 12y cubed. 4 times 3y cubed would be 12y cubed, positive 12y cubed. And positive 4 times negative 4 would be negative 16. And once again, we notice our middle terms cancel out. So I'd have 9y to the 6th minus 16. Okay, so that is our 3 types of special products. Okay, we have the square of a sum, the square of a difference, and the product of a sum and a difference. Okay, so those are our 3 types that we're going to look at. Let us know if you guys have any questions, and we'll see you next time.